Hello all, good evening. Welcome back. Welcome for the next session on Algebra. Okay, so well, we have looked at lot many things so far in Algebra. We have looked at linear equations, quadratics, um, indices, inserts. We have looked at also recently we have seen a lot of sessions on Diophantine equations, wherein we are looking at questions on the integer constraint based problems. So there is still a lot more to go in algebra, and the next segment is of inequalities today. So equations and then inequations go hand in hand, and they have their different set of logics, right? Inequations have their own set of logics based on which they are solved. There are some governing uh, thought process behind each behind solving each problem on inequality. The underlying rule is whenever you have an inequality and you have some expression on the left hand side and on the right hand side, right? If you have expressions only as in uh, as we see some kind of equation on both the sides, then we can transpose the terms on both the sides. But the complexity starts to appear when we have things in the denominator also, right? And then the logic starts to appear. So the most important thing to take care of with inequalities is you cannot cross multiply. You cannot just start to do that cross multiplication thing as we do with equations. So that's the most important criteria. So that we'll illustrate and understand through problems. Let's jump in. Here is the first one. What values of x satisfy this inequality that we have in front of us? uh, Quadratic over quadratic more than one. So if you are inclined to do, okay, let me just cross multiply and say, okay, x square minus 5x plus 6 is more than x square minus 4. Now that is the biggest blunder that you can do. First of all, let's understand why that is not allowed and what should be done if we cannot cross multiply. Why can't we cross multiply? You see, ultimately these are variables. Okay, so they can take different values depending on what value x is assigned. Now let me talk with numbers. It would be easy to understand. Let's say I'm saying that uh, minus 5 over minus 4 is more than 1. Is that correct to say? Well, yes, minus 5 upon minus 4 is same as 5 upon 4, and 5 upon 4 is more than 1. But if I cross multiply and take minus 4 on that side, is it correct to say that minus 5 is more than minus 4? No, minus 5 is not more than minus 4, minus 5 is less than minus 4. So do you understand the logic? What I'm trying to say? Why it is not allowed to cross multiply now, is that making sense? We do not know that the variable quantity, the expression on the left hand side, the numerator and denominator, are they positive, are they negative? So therefore, through this illustration, I hope you can understand, it is not allowed to cross multiply because you don't know the sign of the expression that you are multiplying with on both the sides. Hence, if that is not allowed, then what is it that you should be doing? If you cannot cross multiply, then how do you solve? That's the next thing. You take one on this side and then you simplify and then you solve, which means you say, okay, this is there, let me bring one on the left hand side and then let me simplify. So x square minus 5x plus 6 over x square minus 4, and if I bring minus 1 on this side, so minus 1 would be then more than 0, which further simplifies as whole denominator of x square minus 4, and on the top you have x square minus 5x plus 6, and minus of x square minus 4 means minus x square plus 4 greater than 0. First of all, the quadratic thing goes off in the numerator. At least I have a simple term, and then I can say, okay, This is 10 minus 5x, or let me take 5 common. 5 is common. 5 into 10, it was 10 minus 2x. Sorry, 10 minus 5x, so 2 minus x. And now let me factorize the denominator also. X square minus 4 is x minus 2, x plus 2. Very simply, is greater than 0. This 2 minus x, I can take minus 1 common outside. So minus 5 into x minus 2. So x minus 2 in the numerator denominator will go off. Is greater than 0, x minus 2 goes off. So this is very simple. This is just saying minus 5 over x plus 2 should be positive. Minus 5 is negative. Minus 5 upon something needs to be positive. So something in the denominator needs to be negative for this to happen. Right? Minus 5 over x plus 2 will be positive if x plus 2 is negative. So x plus 2 should be less than 0. So x should be less than of minus 2. That's my answer. X should be less than minus 2. You see, if you had cross multiplied, I'm just showing you, this answer is done. But if you had cross multiplied, what you would have got? X square minus 5x plus 6 greater than x square minus 4. First of all, this is blunder, but I'm showing you what is the result of this blunder. X square will cancel and you will say, okay, 5x comes on this side, let's say 5x is less than 4 comes this side, 10, x is less than 2. And that is also one of the options, and that is a trap option. Now you understand the thing, right? The exam setters put in all the trap options for you to get trapped in, right? So the crux of solving inequalities is you're not allowed to cross multiply. You should take all the terms on one side, simplify, and then work with this. Means you should have 0 on the other side. That's as simple as that. Don't forget that. Okay, perfect. So let's practice further on this. Now bringing in higher degree polynomials with the next one. And also the integer counting is there to this question. Not the range is asked, but question is asking the next one. How many integer values of k satisfy this inequality? All right. So how we will do this? You can see that there is a quadratic expression on the left hand side and the right hand side has a fraction and x in the denominator. So you can understand that by taking all terms on one side, we'll ultimately get a cubic kind of a thing, isn't it? When we'll take the LCM. So we have to deal with that. Let's see. So, therefore, let me bring this term on this side. Or let me do one thing. Let me take 7 minus x square on the right hand side. 6 over x plus x square minus 7 is less than equal to 0. I hope we all know that if I take these terms on that side, then from that side I'm looking at less than equal to, right? From this side I'm looking at greater than equal to, and from that side it will be less than equal to, right? Okay, so taking the LCM, therefore taking the LCM x, right? Don't cross multiply. Don't say, okay, I'm solving for 7x minus x cube is more than greater than equal to 6. Don't do that. Let me remind you once again, don't do that. That is not allowed. Okay. Now, taking the LCM, so x cube, let me write in the order of the degree, x cube and plus 6 minus 7x plus 6. That is less than equal to 0. Perfect. X cube minus 7x plus 6. Okay, so I guess I do need to factorize this cubic, isn't it? Only then we can figure out the solutions. We're looking for the integer solutions. Okay. It is very easy to understand. 1 minus 7 plus 6 is 0. So for the numerator cubic, x equal to 1 is a root, right? 1 minus 7 plus 6 is 0. So x minus 1 must be a factor. Let me factorize x minus 1 from this cubic. I'm separately writing the expression for x cube minus 7x plus 6 in its factorized form. So if I have to factorize out x minus 1, then each term I should write such that x minus 1 has been factored off. So since I see x cube, I should write x square into x minus 1 in order to get x cube. Then I'm getting minus x square, but there was no minus x square to begin with. So I should do plus x square. To get x square, I should write x into x minus 1, so that I have now cancelled the x square, minus x square plus x square. Now I am getting the term minus x, but there is minus 7x. So I should write minus, sorry, this is minus 7x plus 6, right? So this is minus x and this is minus 7x. So I should write minus 6x, and minus 6x plus 6 automatically gets factored off with x minus 1. Basically, I have divided the q1 cubic by the factor x minus 1, and I have got the remaining factor, which is these expressions x square plus x minus 6, x square plus x minus 6 into x minus 1. That is the numerator, right? So our expression becomes, as it has been factorized now, x minus 1, and this x square plus x minus 6 also is, we can understand it as, it is a very simple factorization, x plus 3 x minus 2, right? Minus 6 and plus 3 minus 2. So this becomes x plus 3 x minus 2. Very simple. So it has very simple roots, 1, minus 3 and 2. And in the denominator we have x. This needs to be less than or equal to of 0. Now whenever we have this kind of thing, then what you should do is you should plot the roots of the expression on the number line, that so that you can easily understand where do the thing become positive and negative. So 1, minus 3 and 2, minus 3 first of all on the left hand side, then I will have 1 and 2. And remember, since denominator is x, so x equal to 0 is also a point where the sign of this expression is bound to change. At 0 the function will be undefined. At minus 3, 1 and 2 the function will be equal to 0. To the right of 2 the function will be positive, simply because all the terms will be positive. If x is more than 2, then x minus 1, x plus 3, x minus 2 and x, everything is positive. At 2 it goes to 0 between 1 and 2. So after 2 x minus 2 was positive, but before 2 x minus 2 is negative. So initially after 2 all the four expressions were positive, 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 but this now becomes negative. So the sign of the expression will change and it will become negative in the range of 1 to 2. So the point is that at every root the sign of the expression will change, right? Again at 1 the sign will change, because now two terms are negative, negative negative makes positive. So once again the expression becomes positive. At 0 the function is undefined, remember, not equal to 0, because x is in the denominator. And likewise again, at 0 the sign will again change and go negative, because x is positive for x more than 0, x is negative for x less than 0. And again at minus 3 the sign will change and it will become positive. How many integer values satisfy this inequality? So we have this, which would be less than equal to 0. Remember, at 0 it is not defined. It is not defined. But at minus 3 function is 0. So minus 3 is one such value which satisfies this inequality. Since the function is negative in the range of minus 3 to 0, so minus 2 and minus 1 are also the values of integer values of x for which it is less than 0. 0 has not to be considered, function is completely undefined. Between 1 to 2 function is negative, and at 1 and 2 it is equal to 0. So 1 and 2 will also be taken into consideration, because at those values function is equal to 0. So we have this list of 5 integer values of x at which it is satisfying this inequality. Perfect. So I hope this process is clear. Take terms on one side, simplify, factorize, then plot all the roots of the expression, and then look at the sign, right? To the right side of the largest root, the function is always going to be positive, and at every root, the sign will keep on changing. All right. Now, so bringing in some more logic with the next one. We have been solving inequalities so far. That is a traditional uh, type of questions, but this one is something new. For how many positive integers n is it true that 1 over n plus 1 over n plus 1 is more than 1 by 500? Now I will let you think on this for a minute. Let me see if I get some answer on this. Let me know if uh, you can think through this one. Well, I'm waiting. Let me see. Let me know what you think. Okay. Uh, I'm still waiting. So I'll start discussing. In case you get some idea, do let me know. Now, this question is not something which we can algebraically solve, because it is asking for a condition on n which is positive integer, and it should satisfy this inequality. If we properly start to solve this inequality, first of all, it will become a very complicated quadratic inequality with large coefficients, and methodically solving for that and getting the range of values of n can be done. But even with calculator at your disposal, at least 3-4 minutes are gone easily, right? So the point is that not every question on inequality has to be necessarily solved algebraically. You can do number fitting, which we have been doing so many times in the recent past. We have done number fitting and number plugging so many times, isn't it? And that is what this question also demands. We are looking for positive integers. We are looking for positive integers values of n to satisfy this. What is the first positive integer? Which is the first positive integer? Right? 1. So if I plug in 1, then 1 over 1 plus 1 over 2, the left hand side, is obviously much more than 1 by 500. It is 1.5. Then 1 upon 2, n is equal to 2. Obviously, it will still be much more than this. Right? 1 by 2 plus 1 by 3 is 5 by 6, is much more than 1 by 500. Till what limit do you think we will start to get? I mean, we can understand that from 1 and onwards, we will keep on getting yes for the inequality. At some point of time, we are supposed to get a no. Now, since 1 by 500 is a very small number, so the point means the value of n at which this inequality will not be satisfied. Can I say n will be very large? N will be very large, right? So 1 by n and 1 by n plus 1 will be very closely put together. They will be very, I mean, they'll be very equal, very much close to each other with a very small difference. So nearly, can I say, each of them will be half of this 1 by 500, because just when the question, when the inequality would go wrong, then we would just cross that limit where each of them were almost equal to half of this. So just think about, each of these terms, 1 by n, let's say, is half of 1 by 500. At that point of time, what would happen? So what would happen, let's say, at n equal to half of 1 by 500, which means when n is 1000, not 500 sukun, but 1000, n 1000, right? Sukun, you're thinking with me, very good, right? So you see, n is not 500. N has to be near to 1000 when this inequality will just cross the limit, right? So can I say that if I put n is equal to 1000, then 1 by 1000 plus 1 by 1001 is less than 1 by 500? Because if this 1 by 1000 and 1 was 1 by 1000, this second term, if it was 1 by 1000, then the sum would have been exactly 1 by 1000 plus 1 by 1000, which is 1 by 500. But now the denominator has increased, so this, can I say, is less than 1 by 500? So here the inequality goes wrong, means it is not satisfied. But prior to this, at n equal to 999, what would have happened? I will have 1 by 999 plus 1 by 1000. Is this more than 1 by 500? Yes. So this is that point, this is that limit where the inequality just shifts from yes, the inequality is satisfied, to no, it is not. And hence the answer is this 999 itself, because from 1 to 999 it is satisfied. So that's what I'm saying. Not every inequality has to be algebraically solved. Sometimes you have to do number plugging, number fitting, right? Algebraically solving it can be time consuming, challenging, even with calculator at your hand. Minus b plus minus square root of b square minus 4ac is easier said than done with such large coefficients. You can do this. You can do this exercise at home, that solve this quadratic inequality algebraically. You will realize the challenge. Right? Okay. Yes. Yes, Sukun. Okay. Now let's look at some previous year questions. Let's look at how things have been asked, right, under inequalities. Some of them are standard algebraically solving type questions like this cat 24 last year problem. uh, Now, given that I have discussed the concept behind solving inequalities, we should be doing this very yes, we should be able to do this. Okay, so let's do this together. Let's see who can do this fast. I'm looking at the chat box. If you're getting the answer, do let me know. Okay, now I'm taking this LHS to the that side, and I'm writing 1 over 2x minus 3 minus 1 over x plus 5, right? This goes over, and from there I will see greater than equal to, so this is greater than equal to 0, right? And then let's further simplify. So I have 2x minus 3, x plus 5, so x plus 5, right? And minus of 2x minus 3, so minus 2x plus 3 greater than equal to 0, which means uh, 5 plus 3 8, and minus x 8 minus x over 2x minus 3 x plus 5 greater than equal to 0. Now this is very similar to something that we saw little earlier with the second problem, in which we plotted the roots on the number line and then we observed the change of sign happening, right? Now whenever I get this kind of expression, what I always do is I make sure that the coefficients of x are positive. Right now I have 8 minus x, right? So let me multiply with minus 1 on both sides of this inequality, so that I have x minus 8 instead of 8 minus x. And the basic rule of inequality is that if you're multiplying with minus 1 on both the sides, then the sign of the inequality will shift, will swap, will change. Means if it is greater than, it will become less than. If it is greater than equal to, it will become less than equal to, right? So x minus 8 over, right, 2x minus 3 and x plus 5, there it was greater than equal to, now I will write less than equal to 0, right? And now I will plot the roots on the number line. So here it is 8, then there is minus 5, then this is 3 by 2. Minus 5 is the smallest, and at minus 5 function is undefined. And at, so let me also write not defined so that I'll remember. And then 3 by 2 will come for 2x minus 3, x equal to 3 by 2. And for x minus 8, I will have this 8, right? So now since all the coefficients of x are positive, so to the right side of 8 means for x more than 8, the function will be positive because all the three terms are positive. At 8 to the right, will have that change of sign. It will go from positive to negative because x minus 8 term will become negative. Remember also, let me also mark 3 by 2 function is undefined. X at x equal to 8 function is equal to 0. See, the point is we are solving for less than equal to 0, so we have to be very careful that which are the points at which the function is equal to 0, right? Remember, the roots of the denominator are those points at which the function is undefined, right? Okay, likewise at 3 by 2 there will be a sign of, there will be a change of sign, right? From negative it will go to positive, and again at minus 5 there will be a change of sign. Perfect. Now we are looking for less than equal to 0, so either it is this range x less than minus 5, right? Either x is less than minus 5, or it is this range from 3 by 2 to 8, right? So x will go from 3 by 2 to 8. Remember, minus 5 and 3 by 2 are not to be included, but 8 will be included because at 8 function is equal to 0. So the very first option exactly states this. You see, such a standard basic question of inequality, as long as you know the principle of how to solve an inequality, right? People who have not taken this session, they will do, okay, 2x minus 3 is less than equal to x plus 5. Oh my god, blunder, right? So don't do that. Yes, Sukun, it is a, right? All right, fine. Let's see a few more problems on previous year. I'm taking a ZAT question now, and this is very much in the scope of what we have discussed. Let me again give you 1 minute to think on this. Let's see if somebody can give the answer. Okay, let me start discussing. If you get the answer, do let me know. Fine. Now, so this is very much, you can see it's a polynomial, right? All the in written in the factorized form already. All the factors are written: x plus 4, x plus 6, x plus 8, and it's a sequence. He's saying dot 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 means 4, 6, 8 dot 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 98 means these are all even numbers. So lots of terms, right? 4, 6, 8, 10, 12, and so on. So the roots of this polynomial will be minus 4, minus 6. Okay, you're saying e. We'll just check. Right, so lots of terms. The number of integers x for which fx is less than 0 is what? Okay, Sugun, I'll suggest you to just double check because he's asking for less than 0, not less than equal to 0. Let me point this out. Okay, just reconsider your answer. Let me start discussing. So since this is already written in the factorized form, I just need to plot the roots on the number line and analyze. That's all. The roots are going from smallest one is minus 98, and all the even roots are there: minus 98, then there will be minus 96, right? Minus 94, and so on, right? And dot 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 minus 90 until, let's say, I'll have what, minus 10, minus 8, minus 6 minus 4. To the right side of minus 4, the function will be positive because all the terms are positive to the right of minus 4, right? We just discussed, Kun. Right. So to the right of minus 4, it is positive, right? Between minus 6 to minus 4, it will be negative. Between minus 8 to minus 6, it will be again positive. Between minus 10 to minus 8, it will be again negative, and so on. The alternating signs will appear. Now understand the pattern. When we are changing the sign at multiples of 4, right? Minus 4, minus 8, we are going from positive to negative. Minus 4, positive to negative. Minus 8, positive to negative, right? So minus 92 is a multiple of 4. So we'll go from positive to negative, right? So let's continue this now. So now, right now, so now I have got the pattern on this side because we have to understand the transition, right? So all numbers are even. All numbers are even. So every alternate number is a multiple of 4. So that is why I'm talking about this logic of multiple of 4, right? At multiples of 4, we are transitioning from positive to negative, right? So 92, positive to negative, then plus, then minus, then plus. Now the question is asking the number of integers x for which fx is negative. Now, the mistake, Sukun, you have done, you will realize now. We are not negative for an infinite number of integers, first of all, because both to the right of minus 4 and to the left of minus 98, we are always positive, right? So on the infinite side means till plus infinity and minus infinity, we are always positive. We are only negative between this range of numbers, and we're looking for integer values. So coming from the left rightmost side, we are negative for the first time at the integer value of minus 5. Remember that at minus 4 and at minus 6 we are 0. We are not negative. We are only negative for that integer between minus 4 to minus 6, which is minus 5. And again, the next time we are negative in the range of minus 8 to minus 10. So then minus 9 is the next occasion, right? So what are these numbers? These numbers, can you see, can you understand? So 4 plus 1 5, 8 plus 1 9. So these are multiples of 4 plus 1. For example, the next occasion, you can see over here also, we are getting what? A multiple of 4 plus 1 minus 93. And last occasion will be this number minus 97. So all of these numbers are a multiple of 4 plus 1 with a minus sign. Starting from 5, which is 4 into 1 plus 1, going up to minus 97, which is 4 into 24 plus 1. So how many numbers these are? Not 49, not 48, 24. Right? 4 into 1, 4 into 24. Right? So this sign change logic, right, is very crucial, very important in problem solving. All right, good. Now let's see. Okay, another recent year question from CAD, and it's a very analytical problem. You can see the way options are there. We don't have to we don't have to solve some inequality. We do have to solve it, but then at the end we have to analyze it. So the answer is not okay, what is the solution of this inequality? The it's So first of all, two variables are involved in this inequality. We have been solving questions with one variable so far. This inequality involves x and y at the same time, so we cannot solve this inequality, but we can analyze it. Any non-zero real numbers x, y such that y is not 3 and x upon y is less than x plus 3 upon y minus 3 will satisfy what condition? And all the options are, except for the option D, all the other options are conditional things. If this, then what? Okay, so let's see how do we get this, right? So such typical algebraic analytical questions are also there. So I'm bringing in all the variety, right? All the different types of things we can be asked. Now let me do one thing, the obvious thing. Let me take all the terms on one side. uh, So let me take this term only on this side, or this on that, anything will work. Let me say x plus 3 over y minus 3 minus of x over y, so greater than 0 from that side, right? And then let me just work it out. Y into y minus 3, x plus 3 into y, x plus 3 into y minus of x into y minus 3. And then I'll further simplify y into y minus 3. And here I get xy plus 3y minus xy plus 3x. Xy minus xy goes off, and this is more than 0. Okay, perfect. 3y plus 3x in the numerator. So I get 3 into x plus y over y into y minus 3 is positive. Now I see some, terms and numbers over here which uh, might make sense. See, the denominator is only having y in it. The numerator is having x plus y. What should I do? I should analyze the denominator separately and then look at the numerator. A fraction is positive, right? Something like what we have is something like a over b is more than 0. So either a and b are both positive, or either a and b are both negative, obviously, right? A fraction is positive, so either you have 2 upon 5 or you have minus 2 or minus 5. So what I'm trying to say, on there are two possibilities, right? There are two possibilities. So I'm analyzing how this inequality can be satisfied, because that is what I have to do. Which of the following condition can be satisfied? So if the denominator is positive, so if y into y minus 3 is positive, and now when is y into y minus 3 positive? This is a standard quadratic inequality. A quadratic equation is positive outside the roots, right? So roots are 0 and 3 for this. So can I say for y less than 0 or y more than 3? So if y is satisfying these range of values, if this is happening, then x plus y also should be positive, right? Now do I see something of that sort? You see, minus x more than y, minus x less than y. So all of these are pointing to x plus y only. Now y more than 10 basically means y more than 0. Sorry, y more than 10 basically means we are in the range of y more than 3, right? Option A, if I'm trying to see. So if this is the case, then x plus y should be more than 0. But if I carefully look at this, if x minus x goes over there, so x plus y is less than 0. So this is exactly the contradiction of the condition that should be satisfied, isn't it? Once again, I am saying if y is more than 3, then x plus y should be more than 0. If y is more than 10, then y is more than 3. Then x plus y should be more than 0. But here, this is saying x plus y less than 0, which is a contradiction. Option B, I don't think so. I can say something about if x less than 0, then what? Because the condition starts from y. So my eyes will now turn to option C. If y is less than 0, and that is exactly what I've written over here. If y is less than 0, then x plus y more than 0, and exactly that is written over here. Minus x less than y means x goes over here, x plus y more than 0. Yes. So a subset of the solution is written basically in the options, right? You see, conceptually, we have done exactly what we did in the first few questions only. We have just analytically and solved the problem. But here, the answer is not in terms of numerical values, but in terms of variables themselves, because there are two variables involved. Perfect. Okay. Okay. So ready for the last question of the session? Let's see. Oh, at the end, I wanted to finish and illustrate how inequalities can also be asked through word problems, right? When we solved linear equations, quadratic equations, Diophantine equations, we had so many word problems, isn't it? So even inequalities can be a medium to ask questions through word problems. All right. Uh, a cat question, 2013. Let's jump in. In a bag, there are 150 coins in three denominations: 1 rupee, 2 rupee, 5 rupee, with at least one coin of each denomination being present in the bag. Wonderful. Three parameters I'm clear with, I'm dealing with. Number of coins of the three denominations. At the end, look at the questions, find the total number of 2 rupee coins in the bag. So my target is clear in my mind. I will create XYZ three variables and start to solve for Y, the number of 2 rupee coins. But wait, hang on. Don't create three variables, just scan through the information. The total value of 1 rupee coins is at least 50%. So this is the inequality. At least means, at least is a word which translates to greater than or equal to. I have at least 100 bucks in my pocket. So I have a greater than equal to 100 in my pocket. I could have 100 rupees, I could have 120 rupees, I could have 101 rupees, but I cannot have 99 rupees. If I have said that I have at least 100 bucks in my pocket, right? So this is an inequality statement. Da da da. If there are 23 5 rupee coins, so straight away you don't need to take that Z. You know that there are 23 5 rupee coins. And then again, an inequality is there. Total value of 2 rupee coins is at least 3% of the total value of the coins in the bag. Then, okay, so I'm clear. I just need my two variables, X for the number of 1 rupee coins, Y for the number of 2 rupee coins, and I'm asked to find the value of Y. How do I solve Y? We know that every inequality solution is always a range of values. So how do you expect to solve for the unique value of Y? There is no option of cannot be determined also. That is the wonderful thing over here, isn't it? But the thing is, question indicates that you should be able to get the answer. Now that's the beautiful thing about this question. Let's write everything. Let's write whatever we can. We know 23 5 rupee coins are there. So from 150 total coins, 23 are gone. How many are left? 150 minus 23, 127. So X plus Y is 127 is my first equation. Others, I don't will have equations. I will have inequality conditions. Let's write that. The first one is total value of 1 rupee coins is at least 50% of the total value of the coins in the bag. Okay. Okay, now think about this. You have 1 rupee, 2 rupee, 5 rupee. If 1 rupee constitutes at least 50% of the total coin, total worth, it means the others, which is 2 rupee and 5 rupee coins, this is greater than equal to, remember. So these constitute less than equal to 50%. So can I say effectively the worth of 1 rupee coins is greater than equal to the combined worth of the 2 rupee and 5 rupee denominations? I'm just making my life easy to write the inequality condition, right? Agree? 1 rupee coin worth is more than at least 50%, greater than equal to 50% of total worth. So if this is greater than equal to 50%, the other two taken together, the total worth of 2 and 5 rupee denominations should be not more than 50%, less than equal to 50%. So worth of 1 rupee is more than or equal to the total worth of 2 and 5 rupees taken together. So my condition is X, because right, the worth of 1 rupee coins is simply X into 1. X is greater than equal to, for 2 rupee and 5 rupee, so 2 rupees into Y, the worth of those, plus of 5Z. And Z, I mean there is no Z, that is simply 23. 5 into 23, 115. So I basically have that X is greater than or equal to of 2Y plus 115, right? Okay, so this is my condition. Now I can do something with 1 and 2 now. I can since I have to analyze on Y, I can put in X as 127 minus Y over here and then see what we get on Y. Let's do that. So X is 127 minus Y. So 127 minus Y is greater than equal to 2Y plus 115. Y comes over here, 3Y. From there, I will write less than equal to of, and this comes over here, 127 minus 115, which is 12. I get a very beautiful condition at the end, means a very nicely put Y is less than equal to 4. So you see all the options are 1, 2, 3, 4. Oh my God. How does this help me? Nothing, but at least I see, okay, Y is less than equal to 4. Fine. So this does not help me to get the answer, but this just validates that all the options are correct. All right. Nonetheless, we are expecting to get something from the other. constraint, right? This other constraint of the total value of 2 rupee coins, this condition, right? So let's now write the, again, this is at least means greater than or equal to, right? The value of 2 rupee coins, so value of 2 rupee coins is 2y, is at least is greater than equal to 3%. 3% means 3/100th of the total value of the coins in the bag. Total value of the coins in the bag is x plus 2y plus 5 into 23,115. Hopefully we should get something from here. Also, I would want to get rid of x from here. So what I'll do, cross multiply 100 into 2y. 200y is greater than or equal to thrice of, let me do one thing, x plus y is 127. So let me write 127 in place of x plus y. Okay, and then there is one more extra y remaining in, so I'll write that y. Make sense? X plus 2y is as good as x plus y, so I put in 127 for x plus y. Okay, which is y plus, this is 1, and 27 and 15 is 42, so 142, right? Perfect. 200y is greater than or equal to of 3y plus 14 3s are 426. 197y, 200 minus 3 is greater than or equal to 426. Y is greater than or equal to, sorry, my bad, I just did a small blunder over here, small mistake. This is 242, right? Yeah, so this will be 726, right? 726. Okay, so 19 into 3 is 57, 19 into 4 is 76. This 726, if I divide with 197, it is going to be somewhere in the range of 3 to 4. So y is greater than or equal to 3 point something, 3 point something. Y is less than or equal to 4. Y is greater than or equal to 3 point something. So more than 3, and obviously an integer means 4, right? So the thing is that we got a unique answer at the end of the day, simply because the two inequality conditions pointed to a unique answer, right? So with this, we are clear, and we have with us the sufficient logic to deal with inequalities. We should know that cross multiplying is not allowed. And when dealing with polynomial based problems, we should use the sign change concept, plot all the roots. As we have seen with many questions have been asked on that. Through one question that I took, the third question, I illustrated also that sometimes number plugging can also be required in inequalities. Not always you should just blindly start with, okay, let's start solving the inequality. Right, so that is the crux of today's session. Uh, right, so let me know anything that you would like to ask me. I'm there. Please stay connected, and leave any of your queries on the chat box. I'll see you very soon with the next session on algebra. Algebra is very deep and vast, but we are here to tackle it, right, together. So thank you, and see you quite soon. Thank you.